Okay, so we also evaluate this integral. And to do this, we're going to use trigonometric substitution using the tangent substitution. So basically, to accomplish this, we first have to draw a triangle. Since we're going to be using a tangent substitution, we put our x on the opposite side of the angle. So this is theta. And then we place our adjacent. Our adjacent side should be the square root of 25, which is 5. And then our hypotenuse, using Pythagoras theorem, should be 25 plus x squared. And now we just let x equal to 5 tan of theta. And you can check that this is valid using basic trigonometric, basic trigonometry, right? Tangent is basically opposite over adjacent. And therefore, to find the opposite side, you just you go adjacent times the tangent, which is 5 times tan theta. And now, we differentiate this by saying dx is equal to 5. Now, what's the derivative of tan theta? It's secant squared of theta. Secant squared theta d theta. And now I have this term here, and I'm trying to find a way to substitute back. When I substitute back into this equation, that I should get this term. And I'm going to do that by using the cosine. So the cosine of the angle is basically adjacent over hypotenuse, which is 5 over the square root of 25 plus x squared. And I find that 5 over cosine of theta should equal to the square root of 25 plus x squared. And now I'm basically going to square both sides of the equation. So I get 25 over cosine squared of theta is equal to 25 plus x squared. So this allows me to basically substitute for this term here, basically. And so now, let me see if I can use up this space. Our integral will look like this now. Since we already know what dx is, we go 5 secant squared of theta d theta. And then, now remember that cosine, 1 over cosine is basically secant. So it's the same thing here, saying it's 25 secant squared of theta, basically, right? And so it's just 25, since we're substituting back for this, right? So it's just 25 secant squared of theta. And now, basically, you can just cancel the exponent. Well, you can cancel the secants. And here, 5 comes in here 5 times. 5 comes in here once. And so, what we basically have is just 1 over 5 d theta. And of course, we can take the 1 over 5 out, since it's basically a constant. And now, we just differentiate this. Since we differentiate it with respect to the angle theta, then the antiderivative is basically theta, right? So it's 1/5 times theta. Now we have to substitute back for theta. Now what is theta? Well, basically we have to solve this, right? So if I take this and I divide by 5, I should get x over 5. So let me just show this step by step. So basically, I said x is equal to 5 tan theta. Okay, we have to solve this expression for theta. So it's x over 5. If you're dividing both sides by 5, it's equal to tan theta. And therefore theta is just equal to the octan, or tan to the -1 of x over 5, right? Now, it's a simple matter of substituting here for theta, right? We said it's 10 to the minus 1 x over 5. And of course, since this is indefinite integration, there are no limits. We have to add a constant of integration. And that's basically our answer here.